So it just kind of turned from summer to fall overnight here in Western Pennsylvania. So it's definitely time to get these outlets done so I can get this insulated, drywalled, and get ready for winter. So a few videos back, you saw me install some of these outlet boxes. And some of them I put 18 inches off from the floor. And other ones, like where my workbench is, these are 48 inches off from the floor, from the bottom of the box. I have a few more boxes to put on this wall and 3 more here. So those of you who are new to the channel, you'll see how I properly mounted these boxes to the studs. And then I'm gonna get the office wired as well. So the light boxes have been in for a while. They've got all the wires run to them. I'm gonna install a ceiling fan over here. I'm gonna put the box in and run the wire over. And I'm gonna show you the type of box I'm gonna use as well. So these boxes are about the same. The only difference is the color. So you just want to make sure that you get your typical outlet boxes for this application. But when you go to the store, don't let the color and stuff intimidate you. Basically they're the same. You just want to make sure you get the right type of box for the application. If you do have any questions about the type of box to use, certainly ask one of the sales associates at the store. I would suggest finding some old dude there. He probably knows. So to mount these boxes, I'm going to start by measuring 18 inches off from the floor to the bottom of the box. So these boxes have these little tabs. Pretty much every box you're going to find has these little tabs, regardless if they're light boxes or just regular outlet boxes or switch boxes. So what this does is compensates for your drywall. So when you set these in place, I'll show you on this side first. When you set these in place, it compensates for your drywall, so then your box comes out flush with the drywall. So I have my wire, but I also have some of these little loops of wire. And I'm guessing a lot of you, when you're starting out, you're not going to have these extra pieces here. But what you should always do first is start with your longer runs. And so if this is your panel box, start out by making your longest runs first. And then a lot of times you'll have some pieces left over, maybe enough to go from outlet to outlet. Or like in the office, same thing. The 2 boxes are pretty close together. And so I have these left over from a side job. So I have these, but whenever you're starting out, do all your long runs first, and then you might have extra that you'll be able to use instead of cutting off in the main roll. So as I plan this out where my workbench will be, this will be the first outlet that'll be closest to the panel box. And so if I wanted to run wire to that first box, it might seem really efficient to just, the wire's gonna come out of the top of the panel box, to just drill holes through here and then come over to the panel box. You can absolutely do it that way, and you might have to. But since I have this open framing up here, I'm actually gonna bring a lot of these first runs over to the first boxes. That'll be the first box there. This will be the first box for these 2. And then this one here will be the first box for these 3 that I just installed. And then for the office, actually it'll be that one down there. That'll be the first box. So I'm gonna find creative ways to run this wire through the rafters just because it's gonna save me a ton of time. When I go between boxes, I'll absolutely drill through the studs, but I don't wanna waste all my time drilling. If I can just run through the rafters, it's only gonna use just a few more feet going up and then coming back down. So I'll get all these wires in the panel box later. I just want to get them in place. And what I do is I just write on these, like this one's workbench. So when I put this in the panel, I'll know where it goes. And you'll see that I stapled the wire up there. I stapled about every 16 inches. Where it comes to the wall, where I drilled some holes, obviously it doesn't need to be stapled anywhere around there. That kind of counts as a point where it's being held. But as I come down this 2x4 stud, and when I get to this box, I'm not obviously gonna have to staple all the way down. When I put this wire on here, usually if you're going in between a wall, you want to put it about dead center. In this case, I'm actually gonna cheat it more to the back because I have the room here. And anytime you come into one of these boxes, you want to make sure it's stable. It's by code, it has to be stapled within 6 inches of coming into the box. Okay, and here's the wire in place. Stapled all the way down and stapled within 6 inches of the box. You can leave as much wire out of here as you want. At least leave, 6 or 8 inches. I usually only leave about this, I don't know, about 6 inches sticking out because I'm the one that pays for the wire. So I'm pretty stingy with this. So I marked this wire just like I'm gonna mark all the other wires that power the circuit. And this is because this is where the GFCI outlet is going to be put in place. And it depends, and it absolutely matters how that GFCI outlet gets wired in. If you saw my last video, you'll see why this is so important. So if you're running a circuit where a GFCI outlet is going to be installed, make sure that you mark the Romex that's coming from the panel box, because it's going to be absolutely crucial that you know which wire is which in the box. So this wire that I just pulled needs to get fished up and around and down to this outlet box right here. So this is one of those times where I'm gonna really overestimate how much wire I need to pull through there. You absolutely don't want to make any of these run short because it's illegal to make a splice in behind the wall. So if I ran this wire over and say it came like 2 feet short, I couldn't just make a splice right here in the wall and pull it into the box. I'd actually have to get another box and make it accessible. So I'm gonna way overestimate it. And when I have extra pieces, which I hope I will, then I can just use it for something else. So in typical fashion, I ran out of wire, which is what usually happens on these projects. But I got a lot of the wiring in. So I have this cubby, that cubby, the office, and then these wires in. So what I'm going to use now is these wires that I had started with, and the rest of what's left over from that big roll, just to hop from outlet to outlet. So one thing I wanted to mention, if you have to get an inspection, make sure that all this stuff is done, because it's going to go a long way with an inspector when they show up. If everything's nice and flat, stapled properly, stapled up to code, your boxes are mounted well, that'll go a long way where they won't be looking for stuff. If this all looked like garbage, wasn't stapled properly, and just had a bunch of kinks and stuff in it, they might start looking a lot harder. But here it looks nice and neat. So I definitely try to do that when you're working. So what I'm going to do next is run the wire from that box to this box, and then from this box to that box. So here I'm going to drill holes because it doesn't make sense, especially since I ran out of wire, to go up and come down. So I'll drill holes through here. I had mentioned earlier to put the hole in the middle. I'm still going to do that here. These studs aren't really holding that much except for some drywall and insulation later on, but just for good measure, I'm just going to put the hole in the middle. And something to always watch out for. When you go to drill holes in boards to run wires, make sure you know what's on the other side of them. Make sure that this isn't a gas line or a water, of course, it might be a gas line thing here, but in your home, there might be a gas line behind here, there might be a wire, might be a drain pipe, something behind it. So before you start drilling holes, if it's not open like this, make sure, especially in joists, you know, floor joists, there might be something there that you don't see. So before you drill every single hole, look on the other side, make sure there's not something here. So the last thing I want to get done tonight is I want to get this ceiling fan box put up. I've never used one of these before. The screws and everything look pretty aggressive. I think it'll easily hold a ceiling fan. It's all metal reinforced and everything. That little green screw in there, I'm actually going to put a pigtail on that before I go and put this thing up in the ceiling. It'll be easier to do it down here. It's kind of hard to get inside the box there, so I'm going to use this extension, but I'm going to use this 5/16 nut driver. Third try with a 4-inch extension. Okay, so the nut driver wouldn't finish putting them in either, so 4-inch extension with an extended Phillips bit to get that box mounted. It's pretty solid up there now, but I don't know. I guess if you don't have the right tools the first time, it makes it a little bit difficult. So for the ceiling fan, like I said at the beginning of the video, I can use the 14-2 wire, which the 14-2 is just 14 gauge, 2 conductors, the black conductor, the black wire, and the white wire, and then the ground. And I'm just going to come over from the box and come over between these ceiling joists here and then down to the sub panel. So this isn't going to have a switch on it. And the reason it isn't is because I'm going to have a remote control. So remote control will be wired in up at the box. So when I come in, I'll be able just to hit a button if I want it on. I don't have to have a designated switch. And pretty much that's what most of your ceiling fans are anymore. All they have is that controller box that has that blue wire if you've ever installed one by yourself. All right, day 2 of wiring the outlets. Hopefully I can finish up today. So I went ahead and got all my wires ran. Everywhere has wires now. And here above my sub panel, I installed these 2 boards where I could properly anchor my wires. This isn't going to be a big deal for me because I can insulate behind here, but before you do something like this in your project, make sure that you can insulate around it and that it's far enough that you're not going to end up putting a nail or anything through the wall to hit these. So on the top of your service entry panels or on top of this sub panel, there's all these knockouts. And what I'm going to be doing is just like I did here where I knocked out the metal, put the Romex connector in, and then brought the wire through. I'm going to be doing that in each one of these 1/2-inch holes. I'm going to use as many 1/2-inch holes as I can. There's some that are 3/4 where you can knock out the 1/2-inch first. So I might have to use a few of those. So remember that I labeled each one of these wires. So when I hook them up in the sub panel, I'll be able to record in the door of my sub panel cover where the power is actually going. And so if I ever need to turn the power off, I can just come right over here, look at the list and turn them off. So I'm going to turn the power off in the main panel and get started. So I'm going to use my non-contact voltage tester to make sure that there's no power in this box. Remember how I said to do it before? Check against something that you know has power. So I'm charging up my golf cart here, so I know there's power going to it. So I know that this thing is detecting voltage. Go ahead and just start checking everything. So remember what's specifically hot in this box are these 2 lugs, because these are the wires that come in to the box to feed the power to the box. And then there's going to be these bars that connect to your breakers. These are also going to be hot. So definitely make sure you go around and test these, make sure there's no voltage in the box. So this outlet under the sub panel, it needs to be changed out to a ground fault circuit interrupter outlet. I just threw that one in there just so I could get some power out here. This one in particular, it's the only outlet on the circuit. And so this will be the one that gets hooked into the line. There won't be any wires coming out of the load. And as far as everything else, these outlets will be hot. And then I'm gonna get all these outlets to this point, except for, of course, the GFCI outlets. They'll stay like that. I'll just tuck the wires back in the back till I'm done with the drywall. So I'm going to be putting in a couple different types of breakers. So you see this breaker here is pretty thin, and this one's kind of like your regular size breaker. So they're both the same thing. They both serve the same purpose, obviously rated for different amperages. These are nice when you want to save space. So I'm going to be using a few of these, and I have a few of these left over that I'm going to throw in there as well. Whenever you install these, one, make sure that they're in the off position. Of course, you should have the power off anyway, but make sure that they're in the off position. Right there in the back, there's a screw right there that I'll unscrew, and the wire just feeds in the back there. There's two ways to install these. You can either put them in place, which is what I usually do. I usually put them in place in the breaker box, and then I'll undo the screw first, put these in place, and then feed the wire in and tighten it down. Or if you feel more comfortable, you can actually get the wire, hook it up first, and then hook it into your panel box. So apparently it's mow your grass day. That's why it's a little bit dark in here. I have my garage door shut, and so I just have a little overhead light. So what I'm gonna do is go ahead and install a couple breakers, one of the regular size breakers, one of the half breakers, and then after that I'll open my garage door and do a time lapse. You should be able to see a whole lot better. So to do this job, you're gonna need your electrical screwdriver, some cutters, some wire strippers, a utility knife, and something to knock these out. Usually I just use a hammer. Now keep in mind, you're gonna have to insulate, or you're gonna have to do something probably with these wires. I'm guessing your panel box probably on an exterior wall. So give yourself a little bit of slack in case you got to do something with insulation or make something else work. And these Romex connectors, they hold the wire pretty well. So obviously you don't need to put a board underneath and staple it within 6 inches of the box or anything. This is a okay connection. Take your utility knife and very, very, very carefully start about an inch after the wire comes in to the panel box, or in this case the sub panel. And I just kind of gently let the blade run along the jacket, because you certainly don't want to cut the wires. You just put in all that work running these wires, so you don't want to cause any issues. The last little bit you can cut right through, and then the jacket usually strips off pretty easily. Don't pull the jacket up through your Romex connector. Just kind of get it close up to the top, and then you can just go ahead and cut the jacket away. Now remember, on a sub panel, the neutral and the grounds have to be separated. So in your main panel you don't have to worry about this part, but in this case you do. So go ahead and get the black wire out of the way. This is the neutral side with all the white wires. So just kind of tuck the wire up neatly, kind of along the side. Give yourself some room, and then maybe loop it down and come back. Find somewhere to hook onto this neutral bus bar. Make sure you can see copper on either side of the screw to make sure you get a good connection. Snug it down, and then just make sure you can't pull the wire out. The same thing for the ground. Okay, now for the black wire. Same thing, kind of give yourself a little bit of slack here. Okay, this is the white Romex. This is going to my ceiling fan. So I'm going to be using a 15 amp breaker. So I'll undo the screw here in the back. You have these little plastic clips that clip onto the back. And then you just push down over the metal piece, and that's it. And probably about 3/4 of an inch or so is fine. Try not to over tighten any of this stuff, just get it snugged up. Obviously if you don't get it tight enough it'll arc and possibly cause a fire, but as long as you've got it tied it should be okay, as long as it's pretty snug. So that's it. So if I was to turn this on, it would provide power to the box where the ceiling fan is going to be installed. Okay, I'm going to install the half breaker. These are really nice. Like I said, they save space. If you're doing work for your dear old granny, you probably don't want to use these because they're maybe a little bit harder to see. And of course the button is a little bit smaller. So these are certainly better, but these save a lot of space. I really like these. Maybe when I'm 70, I won't like them as much. Okay, for the half breaker, same thing. Just hooks in the back. The only thing is there's tabs that go one way and then another tab that goes perpendicular to it. This just hooks onto the tab that goes perpendicular. They snap on pretty easy. Okay, and that's it. So at some point my camera turned off, but this is what it looks like. I'm going to be wiring a mini split in my next video, and that's going to go right here. So obviously I couldn't have got all these circuits in place if I wouldn't have used these small breakers. Whenever you go to put these panel boxes back on, obviously make sure you have all the knockouts knocked out properly. I went ahead and knocked out these two just because I'm going to be putting that mini split in at the end of the week. And whenever you go to put these screws back in, be really careful not to strip out the hole. Just kind of get them started in there and just kind of keep everything loose until you get all your screws in, and then you can go ahead and tighten everything down. So at this point in the project, you may have some decisions to make. So if somebody else is going to do your drywall, they obviously don't want the wire sticking out, and so they're probably going to want you to tuck them in. If it's a super professional drywaller, they're probably going to use a little roto zip tool to go around the outlet box. So you're going to want these wires tuck back in there pretty far to make sure the rotozip tool doesn't hit your wires, because that'll cause a big issue, obviously. If you're doing it yourself, you can decide if you want to put your outlets in or not. What I'm going to do right now, because I want some power out here besides just that one outlet that I have over by the panel box, what I'm going to do is go ahead and hook up these two outlets. But what I'm going to do is, when I mount these on here, they're going to have the ears for the GFCI outlet and then the regular outlet. So what I'm going to do is go ahead and hook this up like it would be sitting on top of the drywall. Then when I go to drywall, I'll turn off the breaker, disconnect it, and just turn it sideways, or just kind of like turn it flat. So then I can go ahead and put my drywall on. Then once I'm done completely with the drywall, I can go ahead and reinstall these. And while I'm using it, or while I'm finishing the drywall, I'll also tape them off with some painter's tape just to make sure that they don't get damaged. So if you saw my video on GFCI outlets, you'll know that these are very specific the way that they need to be wired into the ground fault circuit interrupter outlet. So that's why I marked GFCI on one set of wires. So I'm just going to leave about 6 inches of wire sticking out. Strip these wires back. Same thing, don't pull the jacket off past the back of the box. Same thing as in the panel box. You don't want the jacket coming off out of the box. Okay, I'll tuck those up so I know that those are my, or however you want to do it, just make sure you know which wires are which. Okay, strip enough wire off to where you can wrap the wire around the screw and get it tightened down and make a good connection. So when you need to make these pigtails, what's good to use for these is all that wire that you just cut off from other projects like that. By connecting all those breakers up, I have a ton of these little pieces of the white, the black wires, and the copper wire. So I hang on to that stuff and just use it as pigtails so I'm not cutting up good wire. So obviously I need my pigtail from my ground screw to hook up to these two screws. That doesn't change in the ground fault circuit interrupter outlet. So what does change, I don't know if the camera's gonna focus, but you have a line and you have a load. So the line side is always gonna get wires. If this is the only outlet in a circuit, then you're gonna hook the wires up to the line. Of course, the gold is your black screw, and the silver is your neutral screw. And so since we're going to have outlets after this outlet, then those will go in the line side. And so the wires that continue on down the line are going to continue on down the circuit are going to be the load, and the line is going to be the line that comes from the sub panel. So I'll hook these ones up to the load. And these aren't always easy to get on here. And since these screws are going to turn clockwise, you want to make sure that these wires are bent the way that the screw is going to turn. Okay, and then I just use these connectors. I really like these connectors because when you push the wire in, you can see that they've made contact. They go all the way up to the edge of the plastic here, but the metal tab is back a little ways. And so you just push these in there, and I've never been able to rip one of these things out of here. They stick in there pretty well. Okay, the last thing is just to wrap some electrical tape around the outside. Make sure none of the screws can make any contact with anything. Okay, then we'll just gently get all these wires tucked back in the box. So I like this look. A lot of people will turn these upside down so the ground is at the top. I guess the theory is if something comes down, it'll hit the ground first. I guess that's a reasonable reason. Okay, so with this outlet, it's about as simple as you can get. Only gonna have 3 wires and 3 screws to hook up. I want my outlet to go like this, so I'll hook up my wires like that. A lot of people leave these screws out. I always make sure I get them all tightened up even though they're not used. Okay, so the screw is going to go clockwise. So we actually want to turn this wire over. Make sure it turns with the screw. So I just turned the breaker on. So the GFCI is showing that there's power here, but it's tripped, which means there's no power able to go anywhere else. You can't use this. And so if we hit the reset button, then it shows that there's actually power that can leave the outlet and be used. And let me get this to focus in. This is a really handy tool because it shows you what kind of issues you might have with your wiring. And so based on the codes, it'll tell you if it's wired correctly or not. How these 2 lights were lit up and the red was not lit up, it shows it was wired correctly. And what's really handy about this tester as well is this little button will actually cause a trip in the GFCI outlet to make sure it's working properly. So hitting that button trips the outlet, and then we see that it'll reset. So everything's working properly with this outlet. So now let's go over to the other outlet. And if you saw my video on GFCI outlets, you'll see that this outlet should be protected by virtue of the GFCI bit coming after the GFCI outlet. So this is wired correctly. And we just tripped it, but it didn't trip here. It tripped back over at the GFCI. I don't know if you can see the light, but we'll reset it. And the light comes on back over here. So this is the circuit on this back wall. So that outlet by the door will be the outlet that has the GFCI outlet. This will be the intermediate outlet. And that one will just be the last outlet on the wall or in the circuit. So in my electrical basics video, I caught a little bit of flack because I had shown that the way you wire these is you basically have wires coming up at the top and then wires coming down at the bottom. I've seen it wired like that 1,001 times. You can see how, if you watch my video on how I wired the lights, you'll see that I actually didn't do it that way. I pigtailed everything off so only the wires came out to the light. And I do the same thing with my outlets as well. The reason I did it that way is I thought it was a good teaching method. And these are rated. I've talked to electricians since I caught some flack for that. And they say that they are rated to carry the current through here. The issue is if you connect the black and the white wire here and then you connect the other black and the white wire, then of course your grounds come up here. If something happens to this connection here, if this fails, then it'll take out everything after it. I have never seen these fail once. I've never even heard of them failing once. So I don't know what the issue is, but I can see how maybe they would fail, but I mean, that's a pretty durable piece of metal there. So I don't know. I've never seen them fail, but I'm going to show you the way that that I connect them up and most people connect them up. So it's going to be the same process where you just strip the wires back. These wires don't matter. It did matter on the GFCI outlets because you have your line, you have your load. These intermediate outlets, they don't matter. You can hook them up. It doesn't matter which wire goes to, how do I want to say this without getting in trouble? By the time I'm done, it's not going to matter because they're all going to be pigtailed together, and your white pigtail is going to go on the silver screw and your black wire is going to go on the gold screw. And I'll say something and some 40-year electrician will call me out for something simple, so try to be clear. Okay, now you don't want to strip these back very far if you're going to use the connector or the wire nuts because you don't want any metal showing. Okay, so these wires are the wires that I cut off from the sub panel, from putting all the wires in the sub panel. Now if you want to get ahead of the game, you can go ahead and strip all these back and then get them all tucked neatly back in the back of the box, and then your drywaller can come in and finish everything. But like I said, just be careful if you have somebody else do your drywall because they might come in with a rotozip tool and cut your wires. Get that tucked back in the back, so all I have is one wire sticking out, and then by the time I'm done, I only have 3 wires sticking out here. Okay, so now when I come in to wire my outlets, I can just pull those 3 wires out, connect them to my outlet, and then I'm done. So I got a mini split that I'm going to be installing in my next video, so I'm going to be getting ready for that. The mini split's going to go right over here. Hopefully I can get it to a place where it'll miss the projector. I think I can. It'll get installed up pretty high. And so in my next video, this is all going to be insulated and have a vapor barrier on it and drywalled just up to about this point, and then part of the office there, so I can get that installed for the video. But in subsequent videos, I'll show how I insulate this, what type of insulation I use, because I use a different type of insulation for the walls because I find it more convenient. And then I use the regular batt insulation for the ceiling. And the vapor barrier here, the stuff I use requires a plastic vapor barrier. So I'll go into detail of how I get all that installed. And unfortunately my little whiteboard has to come down, and it's actually really heavy the way I made it, so I could lug this thing somewhere. So we appreciate everyone who has subscribed to our channel, and we appreciate the comments that we get, especially the good comments. The bad comments, I guess, help us get better, but we greatly appreciate everyone who has supported our channel, and we hope to see you in the next video.